Two blackouts, one after another, struck without warning. The first, the October 1st US government shutdown, is seared into everyone's memory. But the second, hardly anyone knows it, even happened. On September 1st, a billion-dollar spacecraft locked onto one of the most bizarre visitors our solar system has ever encountered. The pivotal moment came on September 3rd, when history should have been etched in light, yet the cameras went dark. Not for hours, but for days. That once-in-a-lifetime chance gone forever. Accident or deliberate cover-up? What did NASA see that demanded such silence? Tonight we're ripping back the veil on this blackout, and what's revealed isn't just unsettling. It's proof of what many of us have long suspected about this interstellar enigma. If these revelations have your heart racing like they do, mind smash that like button and subscribe now to stay locked in as this story unravels in real time. Drop a comment below with where you're watching from the local time and whether you believe we're getting the full truth or just the story they want us to hear. Want to fuel this truth-seeking community? Share this video on X, Facebook, Reddit, or your group chats. You're the reason we can keep digging into stories like this. Thank you for standing with us. Part 1. The Missing Days. Imagine this. In the first week of September 2025, amid the hum of routine space operations, NASA didn't just flicker off the grid, it plunged a single razor-sharp thread of its vast web into utter darkness. Not the sprawling expanse of the entire space program, not the endless torrent of the internet, but something profoundly specific unfolded a void that defies easy explanation even now. A spacecraft named Psyche. A gleaming testament to human ambition, launched to probe a distant metal asteroid hurtling through the void, millions of miles away, was primed to snap photographs of an extraordinary guest drifting in from the interstellar wilds. That guest, an enigmatic object dubbed 3I Atlas, and per NASA's own transparent public timetable, Psyche was slated to seize those indelible images around September 3rd or 4th, 2025, etching a cosmic milestone into the annals of discovery. But here's where the unease creeps in like a shadow lengthening at dusk. When eager researchers, armed with nothing but curiosity and open access credentials, dove into NASA's raw image database, that sacred repository where every snapshot from Psyche is meant to cascade freely for the world's scrutiny, they surfaced with empty hands. Zilch. No crystalline frames from September the 1st. No glimpses from the 2nd. Nothing from the 3rd or 4th, those golden hours of rendezvous. The silence stretched through the 5th, a barren stretch amid what should have been a flood of data. The archive, once alive with the pulse of progress, simply fell mute. Then, as if on cue on September 8th, the images flickered back to life as though the blackout had never scarred the record. 3 days. A yawning 72-hour chasm in the publicly streamed data of a spacecraft smack in the midst of one of the year's most feverishly awaited astronomical spectacles. And from the halls of officialdom, not a whisper of rationale. No press briefing on a rogue glitch, no memo on archiving hiccups, just the cold echo of absence. Psyche isn't some relic probe rusting in the solar system's forgotten fringes, cobwebbed by disuse. This is a razor-edge marvel, bankrolled by NASA, to the tune of hundreds of millions, bristling with high-resolution cameras, engineered to dissect metallic terrains with the fidelity of Earth's finest lenses. Psyche's very genesis, to tango intimately with the iron-veined asteroid 16 Psyche, mapping its contours in exquisite detail, unveiling secrets buried in metallic sheen. So picture it. This pinnacle of engineering, this chariot of cosmic inquiry, was exquisitely positioned to train its gaze on 3I Atlas as it ghosted through our stellar backyard. NASA's mission blueprint, plastered in plain sight on their public portals, explicitly flagged 3I Atlas as a marquee target, a deliberate waypoint in Psyche's odyssey. No cloaked secrecy, no vault of classification. It was broadcast to the stars and the screens alike. And yet, as the alignment peaked, as the fleeting portal of observation yawned wide, those vital images evaporated from the public eye, swallowed into an unexplained abyss. But what precisely is 3I Atlas? It's no homegrown wanderer bound by our sun's gravitational leash. It's an interstellar interloper forged in the crucibles of some distant galactic forge, barreling through the interstellar abyss at velocities that mock our earthly paces. In 2025, it sliced close enough to Earth to ignite the imaginations of scientists the world over, a siren call for scrutiny. Such visitors are celestial rarities. We don't entertain cosmic drop-ins like this often. When one graces our skies, the astronomical chorus erupts. Telescopes swivel skyward in unison, probes tweak their trajectories with surgical grace. Data surges in torrents, live and unfiltered. These are the instants that redefine paradigms, the sparks that ignite breakthroughs and rewrite textbooks. Except this time, for those 3 pivotal days, the deluge dried to a drip. Nothing flowed, nothing illuminated, nothing shed. The watchdog community, those indefatigable astronomers, armchair stargazers, and data hounds who patrol these digital vaults like sentinels, spotted the rift almost instantly. Alarms blared in forums, threads ignited across the web queries, peppered inboxes from Pasadena to Perth. But NASA stonewalled. No nod to a hardware hiccup, no bulletin on back-end bottlenecks, not even a curt tweet conceding the void's existence. The agency let the quiet metastasize a deliberate hush in an era of relentless revelation. Sure, skeptics might pivot to the US government shutdown looming on October 1st, 2025, whispering of cascading failures in data safeguards or archival pipelines strained by fiscal freeze. Plausible on the surface, perhaps, until you clock the calendar. October's turmoil can't retroactively eclipse September's shadow. An aftermath can't birth a prelude. The chronology crumbles under its own weight, leaving that scapegoat dangling unconvincing and inert. So we're adrift in a riddle untethered to any mundane mishap. No routine upkeep slot, no catalogued catastrophe, no breadcrumb trail of breakdown. Pause here. Let it sink in. We inhabit an epoch of unflinching candor in cosmic cartography, where James Webb's ethereal vistas spill online in near real-time symphonies. Mars rovers' dusty selfies beam back within hours, and a symphony of global agencies pipes petabytes into open-access oceans with mechanical inevitability. Yet, in this pinpoint instance, with this precise probe, this narrow notch of time, this singular stellar stranger, the machinery jammed. The interrogation sharpens not merely what transpired, but the shadowed why lurking beneath. Did Psyche's sights veer astray? Missing 3I Atlas by a cosmic hair? Did the optics betray us at the 11th hour? A cruel sabotage of silicon and starlight? Or did something altogether more arcane unfold a revelation withheld from the record? And here's the specter that haunts the margins. Were the shots captured in vivid clarity only to be excised from the communal feast, deliberately deep-sixed from democratic eyes? What seismic truth could compel an institution sworn to enlightenment to draw such a veil? The answers elude us still. But brace yourself. This lacuna isn't a lone outlier, a fleeting fault line. It's the inaugural fracture in a sprawling mosaic of reticence postponement, an enigma that snakes through rival agencies, overlapping odysseys, and lengthening lunar cycles. This is the genesis of what we've come to term the blackout. And as we tease free this single filament, the grand edifice of NASA and ESA's machinations around 3I Atlas, data begins to fray thread by thread, exposing fissures that shatter our illusions of openness in the theater of space science. Part 2, ESA's 299 glitch and the April 2026 lockbox. While NASA's Psyche probe plunged into an inexplicable blackout over Earth's watchful gaze, a parallel enigma was brewing across the Atlantic, shrouded in the crisp efficiency of European precision. The European Space Agency ESA, for those who track the guardians of the stars, commands a stalwart sentinel of its own, the ExoMars Trace Gas Orbiter, affectionately known as TGO. This orbiting virtuoso, locked in a vigilant dance around the red planet, was primed to scrutinize 3I Atlas as the interstellar wanderer carved its audacious path through the inner solar system's sunlit corridors. TDO's instruments, tuned to sniff out the faintest whispers of atmospheric intrigue, promised a front-row seat to this cosmic flyby, a chance to dissect the chemistry of a visitor born beyond our sun's embrace. In the grand tradition of collaborative science, the ExoMars mission unfurls its treasures with commendable haste. Data cascades to the public domain mere months after capture, crystalline images of Martian dunes, spectral symphonies revealing methane's elusive dance, raw telemetry begging for interpretation. The architecture is deliberate, democratic, forged for sharing, for the alchemy of collective minds, to transmute raw bits into revelations. Yet when intrepid researchers, their screens aglow with anticipation, delved into ESA's meticulously curated data vaults, seeking traces of 3I Atlas, they stumbled upon a timestamp that chilled the blood. Not 2025, not even a deferred 2026. The release dates for pivotal datasets, those spectral fingerprints and imaging halls, were etched as the year 2099. 2099. Let that echo, not a clerical slip hinting at weeks or months of bureaucratic backlog, but a horizon. 74 years hence, a date so remote it mocks mortality itself. It's the digital equivalent of entombing scrolls in a pharaoh's vault, sealing knowledge for generations unborn, or in pragmatic terms, consigning it to oblivion where curiosity withers and the data fades into irrelevance. For most of us, bound by the fleeting span of human years, 2099 isn't a promise. It's a polite exile, a not in your lifetime veiled in code. At first blush, the astronomical chorus dismissed it as a banal gremlin in the machine. A metadata mishap, the kind that plagues labyrinthine databases, where timestamps default to absurd defaults or corrupt in the ether of transmission. Such phantoms haunt even the mightiest systems. A flipped bit here, a rogue algorithm there, and poof dates warp into dystopian futures. But then the plot thickened like cosmic dust settling into rings. The anomalies didn't persist in isolation. They mutated. Not every entry evaporated, but a cascade shifted, realigning to a fresh anchor, April 3rd, 2026. Abruptly, the wait shrank from epochs to mere seasons, 5 months from the initial outcry, though by now, with October's chill seeping in, that deadline looms ever nearer, a tantalizing tease just beyond the horizon. Yet even this concession births its own thorn. April 3rd, 2026 remains a deliberate deferral, a lockbox forged of months, not moments. In the relentless rhythm of space science, where comet tails streak and asteroids whisper their secrets in real time, such a hiatus feels like a chasm. Juxtapose this with NASA's stony reticence, and the divergence sharpens like a lens focusing starlight. Where the Americans excised the evidence, wholesale erasing Psyche's gaze without a murmur, ESA at least extended the courtesy of candor, conceding the data's existence while dangling a future unveiling. It's a half step toward transparency, a nod that whispers, "We have it, you'll see it, eventually." But that very concession, the compulsion to timestamp a delay so stark, unleashes a torrent of disquieting queries. Why would a vanguard of discovery, sworn to the swift dissemination of stellar truths, orchestrate a 6-month embargo on data that should flood the commons like a meteor shower? In the symphony of solar system scrutiny, observations of comets, asteroids, and their interstellar kin typically torrent forth unbidden, immediate, insatiable fueling papers and paradigms overnight. Here, though, the score sours. Both titans, NASA with its veil of void, ESA with its calendared cage, appear to march to an anomalous drumbeat, protocols bent or broken in unison. NASA's hush might masquerade as mechanical misfortune, a glitch shrugged off in the vast machinery of missions. But ESA's calculus, that's the scalpel's edge, a deliberate datum. April 3rd, 2026, inscribed by human hands in some control room bathed in the glow of monitors. Someone chose that date, weighed its implications, and committed it to the archive, a sentinel's decision, not fate's folly. Delve into the annals of orbital odysseys and echoes of embargo surface, faint but familiar. The Hubble Space Telescope, in its fledgling flights, granted proprietary peaks to the architects of observation. Before the banquet opened to all, a grace period for gestation, not gestation eternal. Mars rover's vistas have lingered in labs for weeks, months, at the outer fringe, awaiting the polish of processing. But 74 years, that's not delay, that's decree. A 2099 seal isn't backlog, it's burial. A stratagem to consign the contraband of knowledge to the footnotes of forgotten files where public memory evaporates like dry ice under vacuum. When ESA finally deigned to dissect the anomaly post-murmurs from the vigilant fringes, the verdict landed soft technical tribulation, a metadata malady, a systemic stutter. Plausible perhaps in the trenches of terabyte triage. But that primordial 2989 imprint, it conjures shadows unbound by error. What if it wasn't inadvertence at all, but architecture, a cunning camouflage data shrouded in plain sight amid the archive's mundane sprawl? Envision a placeholder, a digital do not disturb for payloads too potent for premature eyes classified contours, spectra singing songs too strange for the symposium. Exposed by eagle-eyed auditors, it demanded hasty housekeeping, a scramble to scrub and reschedule April 3rd as the new fig leaf. We tread on speculation's thin iced certainty, elusive as a comet's tail. Yet the choreography, the initial outlier, the reactive recalibration, the shift from sci-fi to near-term reeks of orchestration. Choices were made, curtains drawn, dictating the divide between what we witness and what whispers in the wings. The fallout, a seismic shiver through the foundations of trust. If NASA and ESA, pillars of planetary pursuit, sundered by oceans yet yoked in alliance, stray from their sacred scripts in handling 3I Atlas. If both erect barriers where bridges should span, we are no longer chasing solitary snafus. This is constellation, a deliberate divergence, a duet of discretion, treating this wanderer as an outlier of import. The pivot sharpens from what occurred to the abyss beneath. What vista, what revelation ignited such stringent seclusion? What facet of the fleeting flyby, be it image, etched in infrared or spectrum, laced with the alien, commanded this transatlantic tango of restraint? The crux may pulse in the object's own disclosures, for as these vaults sealed shut, a countercurrent stirred nascent images, and spectroscopic whispers of 3I Atlas began to seep through the cracks. And what those portents unveiled, anomalies no comet should conjure harbingers that propel us toward Part 3's unraveling dread. Part 3. The Sunward Jet confirmed. In August 2025, a fresh wave of imagery and data on 3I Atlas broke like a cosmic tide, washing over the astronomical community with revelations that defied expectation. These glimpses, harvested from ground-based telescopes perched on earthly peaks and spaceborne instruments peering through the void, offered a tantalizing portrait of the interstellar interloper. But as scientists pored over the photographs, something jolted them upright. A discovery so jarring, it rewrote the script of celestial mechanics. A jet of material, defiant and unmistakable, streaming toward the sun. To anyone versed in the dance of comets, this was heresy. Comets, those icy vagabonds of the cosmos, follow a rigid choreography when they graze the sun's fiery embrace. Solar heat sublimates their frozen cores, transforming ices into geysers of gas and dust. The sun's relentless radiation pressure then takes the helm, sculpting these outbursts into tails that arc gracefully away from the star, trailing like pennants caught in a stellar gale. This is no mere tendency, it's as foundational to cometary physics as gravity is to a plummeting stone. The tail's orientation, always shunning the sun, is non-negotiable. Yet 3I Atlas, with audacious disregard, spat a jet sunward as if mocking the very laws that bind the heavens. The spectroscopic data gleaned through the keen eyes of the Keck Observatory in Hawaii only deepened the enigma. Light from 3I Atlas, fractured into its elemental truths, revealed emissions of nickel and cyanide, a pairing not unheard of in the annals of comets, but rare enough to raise eyebrows like finding a polar bear in the Sahara. Stranger still, the object flaunted an anti-tail, a secondary plume jutting ahead of its primary tail, pointed in a direction that scoffed at conventional geometry. This wasn't just a quirk. It was a rebellion against every model of cometary behavior, as if something or someone were actively propelling material toward the sun, defying the solar wind's outward shove. Picture the difference between leaves scattered by a storm and a leaf blower aimed with surgical intent. The sun is the universe's leaf blower, its radiance the undisputed force. Yet 3I Atlas seemed to wield its own agency, its own unseen engine. This anomaly dovetailed with earlier whispers from the James Webb Space Telescope, which had peered into the object's coma, the hazy shroud enveloping its core, and found it saturated with carbon dioxide. This wasn't just unusual, it was a chemical fingerprint pointing to origins near the carbon dioxide ice line, a frigid frontier in a protoplanetary disk where CO2 congeals into frost. For a comet supposedly birthed in the Oort cloud, our solar system's icy hinterland, or hailing from the uncharted depths of interstellar space. This composition was an outlier, a riddle wrapped in a mystery. It hinted at a birthplace and a journey that didn't align with any known narrative prodding scientists to question not just where 3I Atlas came from, but what forces had sculpted its strange behavior. The Sunward Jet in particular haunted every mind that grappled with the data. A stream aimed at the sun isn't merely an oddity, it's a defiance of natural mechanics, a phenomenon that no textbook equation could neatly resolve. Consider for a moment a spacecraft, a vessel engineered to roam the stars, to shed excess heat, maintain its course, or stabilize its frame. It might vent material with purpose, directing plumes to harness solar radiation or anchor its trajectory. Such a maneuver isn't random. It's calculated, deliberate, directional. The jet's orientation matters a vector of intent rather than chaos. Could 3I Atlas, with its rogue emissions and unorthodox chemistry, be betraying a design beyond mere rock and ice? The timing of these revelations added fuel to the fire. The August images surfaced just as NASA's Psyche spacecraft, armed with cameras rivaling the finest on Earth, was poised to train its unblinking gaze on 3I Atlas in early September. The scientific community was already abuzz, electrified by the object's non-conformity, its rule-breaking jet, its alien chemistry, its anti-tail that thumbed its nose at celestial norms. Everyone knew something extraordinary was afoot. And then, at the precise moment when Psyche's high-resolution lenses should have delivered the clearest portrait, yet the data stream choked. The archive went dark. 3 days of silence and eternity in the relentless pulse of space exploration swallowed what should have been a defining moment. Those August glimpses had whetted appetites, painting 3I Atlas as a cosmic anomaly that demanded closer scrutiny. The logical next step, sharper images, finer data from Psyche's cutting-edge arsenal, should have been the crescendo. Instead, the Blackout descended, a curtain yanked shut just as the stage was set. The Sunward Jet wasn't merely a curiosity. It was a signature, a beacon of something operating outside the bounds of known physics. When jets point the wrong way, when compositions defy expectation, when anti-tails twist in unnatural arcs, the question shifts from, what is this, to, is this even natural at all? The implications are dizzying. If Psyche's lenses captured evidence of that jet, that chemistry, that deliberate defiance, it might explain the void in the archive. Those images could have unveiled something too seismic for public consumption, something that would force a reckoning with truths the scientific establishment, or those steering it, wasn't ready to confront. A natural object bending the rules is one thing. An object operating by a logic alien to our understanding is another. The silence then wasn't just a glitch. It was a shield, a barrier erected to guard questions too vast, too unsettling to unleash. As the darkness deepened, so did the suspicion that 3I Atlas was no mere wanderer, but a herald of something far stranger lurking just beyond the veil. Part 4. The Silence from Psyche. When the Psyche spacecraft's data stream flickered back to life on September 8, 2025, it resumed its steady pulse of images, capturing the cold glint of distant asteroids with mechanical precision. The mission marched on its archives swelling with crisp frames of cosmic landscapes. Yet, if you combed through every pixel of those photographs, sifted through every NASA blog post, chronicling the mission's triumphs, or scoured the social media feeds of the scientists and engineers steering this billion-dollar marvel, you'd find a void where 3I Atlas should have shone. No mention, no snapshot, no fleeting reference to the interstellar visitor that had gripped the astronomical world just weeks prior. No scientific papers surfaced in peer-reviewed journals. No press releases trumpeted new findings. No casual tweets hinted at what Psyche's lenses might have glimpsed. The silence wasn't confined to the archive's missing days. It permeated every channel, a blackout woven into the very fabric of the mission's narrative. This absence is jarring, especially against the backdrop of the fervor that preceded it. In the weeks leading up to September, the Psyche team had been alight with anticipation. Interviews buzzed with excitement, scientists detailing how the spacecraft's high-resolution cameras, crafted to map the metallic sheen of asteroid 16 Psyche in exquisite detail, could pivot to capture 3I Atlas in its fleeting passage. They spoke of the science at stake, spectral signatures, to unravel its chemistry images, to chart its form insights, to redefine our understanding of interstellar wanderers. The opportunity was circled on calendars, trumpeted in mission briefings, and eagerly awaited by a global community of researchers and enthusiasts. The stage was set for a historic encounter. And then, as the observation window closed, that enthusiasm vanished like a star eclipsed. The scientists fell mute. The mission website, scrubbed clean of any mention, the entire campaign seemingly erased from the official ledger as if it had never been planned. What could explain this deafening quiet? The simplest answer points to a technical hiccup. Space is a merciless arena, and even the most advanced machines falter. Perhaps Psyche's cameras were trained elsewhere when 3I Atlas swept into view, misaligned by a fraction of a degree. Maybe a telemetry glitch severed the data's lifeline to Earth, or a malfunction, say a shutter stuck, or a sensor fried stole the moment. Such failures are not uncommon in the high-stakes ballet of space exploration, where cosmic rays and frigid voids test every circuit. But here's the rub. NASA's playbook for such setbacks is well worn. A press release would typically follow a candid admission of misfortune. Something like Psyche targeted the object, but a communications fault disrupted the feed. Or we captured partial data, but a glitch prevented a full download. These are the routine confessions of an agency accustomed to transparency. Yet no such statement came. The void was left to speak for itself. Another possibility whispers of caution rather than catastrophe. Perhaps Psyche's lenses did capture 3I Atlas, but what they saw demanded pause, something so unexpected, so paradigm-shifting that scientists needed time to dissect it before unveiling it to the world. Calibration checks, peer reviews, or internal debates might have delayed the release as researchers wrestled with anomalies that defied easy explanation. History offers parallels. In the 1990s, the Galileo spacecraft's images of Jupiter's moons revealed geological surprises that took months to verify before publication. But even then, NASA signaled the delay, issuing updates to temper anticipation and affirm that analysis was underway. No such courtesy emerged here. No hint of a holding pattern, no promise of revelations to come. The silence was absolute, a departure from the cadence of open science. Then there's the shadow of a third, more unsettling prospect classification. What if Psyche's cameras captured something that transcended the natural, a structure, a behavior, a signature suggesting 3I Atlas wasn't merely a comet or cosmic debris, but something else? Such a discovery could ripple beyond science into the realm of national security, triggering protocols that lock data behind classified walls. Precedents exist. Early reconnaissance satellites cloaked their imagery for decades, and even Apollo mission recordings lingered in restricted vaults until dogged researchers pried them free. If Psyche's data hinted at an artificial origin, an object shaped by intent rather than eons, such a revelation could justify an embargo ordered from echelons far above mission control. The stakes would be monumental, not just a scientific breakthrough, but a geopolitical and existential quake, demanding secrecy until the powers that be deemed the world ready. This cumulative silence carves a chasm in our knowledge, precisely where clarity was promised. August's data had already painted 3I Atlas as a cosmic outlier. Its Sunward Jet, its cyanide nickel glow, its carbon dioxide shroud, all defying cometry norms. Psyche, with its unparalleled imaging prowess, was poised to sharpen that portrait, to answer the questions those anomalies screamed. Yet, at the critical juncture, the data vanished, and the mission's voice fell silent. This isn't just a gap, it's a roar in reverse, a void so profound it becomes its own signal. In an era where space science thrives on radical transparency, where Mars rovers' selfies flood feeds within hours, and Webb's cosmic vistas stream to open archives, the absence of 3I Atlas from Psyche's record is no accident. It's a choice deliberate and weighty, made by someone somewhere to withhold what the world was primed to see. That choice itself is the loudest data point of all. It whispers of something glimpsed, something so extraordinary, so disruptive, that it was deemed too potent for public eyes. The silence from Psyche isn't just a missing chapter. It's a locked vault guarding truths that could redefine not just what we know about 3I Atlas, but what we dare to imagine about the cosmos itself. Part 5. The Timeline Gap. To unravel the enigma of 3I Atlas, let's weave a unified timeline, stitching together the scattered threads of events across the space agencies entangled in this cosmic mystery. By laying out the chronology, we can trace the shape of the pattern, a silhouette that grows sharper and more unsettling with each step. August 2025. The saga ignites as new spectroscopic data on 3I Atlas floods the scientific community. From the volcanic heights of Hawaii, the Keck Observatory captures the object's light, splitting it into a spectral code that reveals nickel and cyanide emissions, a chemical cocktail rare for comets, jarring in its defiance of textbook expectations. Whispers ripple through academic halls as blogs and preprints pulse with speculation. The James Webb Space Telescope adds fuel to the fire, unveiling a carbon dioxide-dominated coma, a composition that clashes with the notion of an Oort cloud origin or an interstellar pedigree. Then, in late August, a high-resolution image emerges, a visual bombshell, a jet of material stark and undeniable streaming toward the sun. This isn't a subtle anomaly tucked in data tables. It's a photograph, a defiant streak of matter, flouting the sacred rule that gum tree tails flee solar radiance. The astronomical community buzzes with fervor minds, alight with questions about this visitor from beyond our stars, poised for the next wave of revelations. September 1st, 5th, 2025, enter the Blackout, NASA's Psyche spacecraft. A technological titan built to map metallic worlds with surgical clarity, falls silent during its prime observation window for 3I Atlas, scheduled for September 3rd and 4th. The public archive, a beacon of open science, goes dark. No images, no data, no trace of the interstellar guest. 5 days of absence swallow what should have been a historic encounter, as Psyche's high-resolution cameras, capable of etching asteroid surfaces in vivid detail, apparently capture nothing for public eyes. September 8th, 2025. The archive flickers back to life images, resuming their steady flow. But 3I Atlas is conspicuously absent. No frames, no mentions, no hint of its passage. Despite exhaustive searches across NASA's databases, social media and mission logs, the object has vanished from the record, as if the observation never occurred. The silence is total, a stark contrast to the pre-September hype when Psyche's team trumpeted the opportunity in interviews and briefings. October 1st, 2025. The US government shutdown looms a convenient scapegoat for some. But the timeline betrays it. A future event can't erase a past void. The September blackout stands untouched by October's chaos, a red herring that crumbles under scrutiny. October 3rd, 7th, 2025. Across the solar system, the European Space Agency's ExoMars Trace Gas Orbiter TGO reaches its closest approach to 3I Atlas as the object skirts Mars. TGO's instruments, honed for sniffing out atmospheric secrets, are perfectly poised to capture detailed spectra and imagery. Researchers from ESA and global partners should be dissecting this bounty, except no data surfaces in public archives. Instead, ESA declares the information locked until April 3rd, 2026, a delay stretching months beyond the norm. It's not a release. It's a lockbox sealed with a date that feels more like a deflection than a promise. October 25th or 26th, 2025. Another window opens as NASA's Europa Clipper, en route to Jupiter's icy moon, has a chance to train its high-resolution cameras on 3I Atlas. Will these observations materialize in the archives, or will October mirror September's silence? The question hangs heavy with doubt as the pattern of absence grows. April 3rd, 2026. ESA's pledged release date for TGO's 3I Atlas data looms on the horizon, inked on calendars as a commitment. But as we survey this timeline, the weight of accumulated delays and disappearances casts a long shadow. Will this deadline hold? Or will it slip into further postponements, another lockbox in a growing vault of withheld truths? What emerges from this chronology isn't a scattershot of unrelated mishaps. It's a constellation of calculated silences. NASA's Psyche archive goes dark during a critical observation. ESA's data is embargoed for months, initially tagged with an absurd 2099 release, before shifting to a still distant 2026. Europa Clipper's potential contributions teeter on the edge of uncertainty. Both agencies, American and European, deviate from their bedrock commitment to swift open data sharing. This isn't the usual cadence of science where comet tails and asteroid maps flow freely within weeks. It's a deliberate divergence, lockbox dates set far into the future, a spacecraft's silence at its moment of truth, data sets deferred when transparency is the norm. This is no coincidence. Patterns like this don't form by chance. They hint at intention, perhaps coordination. Multiple agencies, oceans apart, treating 3I Atlas with a secrecy that defies their own protocols, suggests a shared calculus, a decision that certain truths about this object must remain veiled, at least for now. The question isn't just what happened, but what could be so seismic, so sensitive, that it compels two pillars of space exploration to rewrite their rules. The answer may lie in 3I Atlas itself, its Sunward Jet, its alien chemistry, its behavior that dances outside the laws of known physics. As the timeline crystallizes, it points to a truth too potent for public view, a revelation locked away, waiting for a day when the world is ready to face what this interstellar visitor might truly be. Part 6, The Lost Windows, High-Rise and Mars Assets, as 3I Atlas swept close to Mars in early October 2025. It wasn't just the ExoMars Trace Gas Orbiter TGO poised to capture its secrets. The Martian skies were patrolled by another sentinel, NASA's Mars Reconnaissance Orbiter MRO, armed with the High-Resolution Imaging Science Experiment, or High-Rise, one of the most formidable cameras ever lofted into space. With a pixel resolution of roughly 30 centimeters from Martian orbit, High-Rise can discern details that stagger the imagination. The intricate swirls of dust storms, wind patterns etched in sand rocks, the size of cars glinting thousands of kilometers below. Given the right alignment, this optical titan could have pierced the veil of 3I Atlas, capturing its nucleus in breathtaking clarity, revealing not just its surface, but its very structure. Was it a shapeless lump sculpted by eons of cosmic chaos, or something sharper, more geometric, hinting at an unnatural origin? The potential was staggering. Yet, where are those images? Have you seen a single high-rise snapshot of 3I Atlas blaze across scientific feeds or public archives? Has any database pulsed with high-resolution glimpses of this interstellar visitor? As of now, the answer is a resounding no. No images have surfaced, no data has trickled to the researchers clamoring for it. If High-Rise turned its unblinking eye toward 3I Atlas, those observations remain cloaked, locked away from scrutiny. This absence echoes the silences of Psyche's Blackout and TGO's embargoed datasets, a chilling refrain across platforms and agencies. The legacy of MRO and High-Rise is one of relentless openness. For nearly 2 decades, this orbiter has beamed back a visual symphony of Mars-cratered plains, sinuous dunes, ancient riverbeds, all released with regularity to public archives. When Martian moons, Phobos and Deimos, drift into High-Rise's frame, those images flood online. When comets blaze through Mars's neighborhood, photographs follow, shared with the world as a matter of course. The default is disclosure. The standard is transparency. Yet when 3I Atlas grazed Mars, when High-Rise had a golden window to capture unprecedented detail, the data vanished from the expected pipeline. Why? The simplest explanation points to logistics. Perhaps High-Rise was tasked with mapping Mars's surface during that critical window, its gaze fixed on rust-red terrain, rather than the interstellar passerby. Maybe mission priorities favored other targets, dust storms or volcanic scars deemed more pressing. Or perhaps the data snared in the complexities of deep space transmission languished in processing limbo. These are plausible hurdles. Space missions are a tangle of scheduling conflicts and technical bottlenecks. But plausibility frays when the absence is total. Typically, a delay comes with a breadcrumb trail, a status update on NASA's data portal, a note signaling processing timelines, a whisper of when the archive might bloom. Here, there's nothing. No placeholder, no promise, no acknowledgement that 3i Atlas ever crossed High-Rise's sights. Consider a darker possibility. What if High-Rise did capture 3i Atlas, its lenses locking on to details that stunned the mission team? What if those images revealed not a ragged comet, but a structure, edges, angles, forms that hinted at something crafted rather than carved by nature? Such a discovery would demand more than routine analysis. It would trigger a cascade of scrutiny from internal reviews to high-level deliberations. The data might be held back, pored over in sealed rooms, perhaps even classified to shield findings too seismic for public consumption. History offers faint echoes, classified satellite imagery buried for decades, Apollo tapes locked in vaults. If High-Rise's frames suggested 3i Atlas was no mere cosmic drifter, but something engineered, the silence would make sense a protective cocoon around a truth too vast to unleash. This void doesn't stand alone. It's part of a broader tapestry. Psyche's 5-day blackout during its observation window, TGO's data locked until April 2026, and now High-Rise's missing frames. Multiple spacecraft, multiple agencies, multiple opportunities to capture 3i Atlas in high resolution, all stifled, delayed, or erased. This isn't a singular glitch. It's a symphony of suppression, a pattern that transcends coincidence. Spectra like those from Keck or Webb tell us what 3i Atlas is made of nickel cyanide carbon dioxide, but images reveal its soul. They show shape, structure, intent. A natural body bears the soft curves of gravity's caress or the scars of ancient collisions. A constructed object might betray edges, symmetry, design signatures that could spark a conversation neither NASA nor ESA seems ready to broach. The absence of High-Rise's imagery, paired with Psyche's silence and TGO's lockbox, paints a picture of systematic withholding. This isn't about one spacecraft faltering. It's about a coordinated decision, likely made far above mission control, to gatekeep observations of an object that defies every expectation. The Sunward Jet, the alien chemistry, the anti-tail all point to something extraordinary. But images, they could confirm the unthinkable, that 3i Atlas isn't just an anomaly, but a herald of something built, something purposeful. That possibility, more than any technical snag, explains why the data remains locked away, why the mystery deepens, and why the silence grows louder with each missed window. Part 7. Plasma propulsion or shield. What if 3i Atlas isn't a comet at all, but a machine, a probe, a vessel engineered to traverse the interstellar void? Its behaviors, not the whims of natural physics, but the deliberate signatures of active systems. The notion teeters on the edge of science fiction, yet the evidence, stark and unyielding, demands we follow where it leads. Community researchers, those tireless sleuths parsing every scrap of data, have spotlighted a peculiar halo encircling 3i Atlas, dubbed Space Invader-shaped for its eerie resemblance to the pixelated aliens of a bygone arcade game. Visible in specific wavelengths, this halo isn't the diffuse dusty coma expected of a comet. It has structure, edges, geometry, a deliberate form that feels almost crafted. Is this merely the solar wind, that torrent of charged particles streaming from the sun, sculpting a natural mirage? Mainstream science leans there, citing plasma distortions or dust interactions as plausible culprits. But what if the halo isn't a passive effect, but an active emission? A plasma field generated by the object itself. Picture a spacecraft, not a lump of cosmic eyes, but a machine wielding electromagnetic shielding or venting ionized gas as a byproduct of propulsion or thermal regulation. A plasma-based system, whether for propulsion shielding or heat dissipation, could produce precisely this kind of halo-structured, edged, and oriented with intent. The Sunward Jet defying cometry norms by streaming toward the sun could be exhaust from an active engine, not sublimated ice. The cyanide nickel emissions and carbon dioxide heavy coma anomalies in themselves might hint at synthetic processes rather than geological ones. The anti-tail twisting in unnatural arcs could signal a system stabilizing itself against the solar wind's push. Together, these traits paint a picture not of a passive rock shaped by external forces, but of a device maintaining its own bubble of control, an artificial entity navigating the solar system's harsh terrain. This hypothesis finds an eerie echo in Oumuamua, the interstellar visitor that stunned astronomers in 2017. That cigar-shaped enigma displayed non-gravitational acceleration speeding up in ways gravity alone couldn't explain. Its odd, elongated form sparked heated debates, with some daring to propose it might be a solar sail, a craft harnessing light pressure for propulsion. The scientific community bristled, clinging to natural explanations. But the seed was planted. An interstellar object could in theory be artificial. 3I Atlas takes this possibility further. We have tangible evidence photographs, spectra, high-resolution glimpses, showing behaviors no comet should exhibit a Sunward Jet. A geometric halo, anomalous acceleration, and chemistry that defies its supposed origins. These aren't vague inferences. They're data points screaming for a new paradigm. Mainstream astronomers cautious by training counter with natural models. They point to carbon dioxide ice lines, rare cometary compositions, or quirky behaviors seen in our solar system's own oddballs. Occam's razor, they argue, favors the mundane over the extraordinary. And they are not wrong. Science thrives on restraint, on exhausting the familiar before chasing the fantastic. But what happens when the familiar falters, when the data strain against every natural model, when jets point the wrong way, when halos take shapes too precise for chance? 3I Atlas doesn't just nudge the boundaries of cometary physics, it threatens to shatter them, forcing us to at least entertain the possibility of something, constructed a probe, perhaps a solar sail, orienting itself toward the sun, to harness its energy, adjust its course or power its systems. Imagine such a craft, a vessel built to roam between stars, using solar radiation as both fuel and compass. Its Sunward Jet could be a thruster firing to stabilize its trajectory during a close solar pass. The halo might be a plasma shield deflecting cosmic rays, or solar wind to protect delicate systems. The asymmetry, the chemical oddities, all could stem from a machine managing its environment with purpose, not a comet passively sculpted by stellar forces. This model, while speculative, aligns with the observations. It isn't disproven by the data. It merely demands a leap beyond conventional assumptions, and that leap brings us crashing back to the silence. If NASA or ESR researchers even suspected 3I Atlas might be artificial, a probe, a relic, a machine, wouldn't that trigger an immediate lockdown? Classified protocols would snap into place, pulling data from public view. High-level officials would be summoned, security reviews launched, and releases delayed until the implications could be weighed. A discovery of this magnitude evidence of a non-natural object traversing our solar system wouldn't just be scientific. It would be geopolitical, existential, a spark that could ignite panic or wonder. The blackout of Psyche's images, the absence of high-rises frames, ESS lockbox date of April 2026, all align with the scenario where agencies glimpsed something too profound to share without preparation. The silence, then, isn't a glitch. It's a strategy. It's what you'd expect if someone peered through the lens and saw not a comet, but a construct, a machine with a halo like a shield jet's like thrusters, and a purpose we can't yet fathom. The data locked away may hold the key to a truth so staggering, it demands secrecy, at least until the world is ready to face what 3i Atlas might truly be. Part 8. The Industrial Alloy Mystery. The spectroscopic data streaming back from observatories tracking 3i Atlas unveils a puzzle that refuses to slot neatly into the well-worn pages of cometry science. Among the chemical signatures detected in the object's outgassing nickel stands out a finding that on its own raises few alarms. Comets and asteroids often bear traces of metals forged in the crucibles of ancient stars. But here's where the anomaly sharpens into focus. The spectra reveal nickel without measurable iron. This isn't just unusual, it's a cosmic curveball. In our solar system, nickel and iron are near inseparable companions, twinned in meteorites, asteroids, and the cores of rocky worlds. Their ratio, a cosmic fingerprint, narrates the story of planetary formation etched in the dust of primordial nebulae. Yet 3i Atlas defies this script, presenting a composition that feels like a deliberate rewrite of the rules. Step into the metallurgical lens for a moment. On Earth, separating nickel from iron is no trivial feat. It demands industrial alchemy processes, like the nickel carbonyl refining technique that humanity devised to isolate pure nickel for specific purposes. We've engineered high nickel alloys, think Inconel, a blend of nickel and other elements crafted for extreme resilience, enduring scorching heat, resisting corrosion, thriving in environments as hostile as the sun's corona. These materials don't occur naturally. They're the product of intentional design forged for durability in the harshest conditions. In space, no known natural process routinely yields such refined compositions. Yet here we have 3i Atlas, trailing a signature that mirrors the precision of industrial metallurgy, its outgassing hinting at a purity and combination alien to the chaotic churn of cosmic debris. The James Webb Space Telescope, JWST, with its infrared gaze piercing the void, adds another layer to this enigma. Its data reveals a coma dominated by carbon dioxide ice, a stark departure from the water ice and volatile-rich shrouds of typical comets, born in the frigid outskirts of planetary systems like our Oort cloud. This CO2-heavy signature points to formation near the carbon dioxide ice line, a narrow band in a protoplanetary disk where conditions favor this specific chemistry. For an object purportedly from interstellar space or even our own solar system's distant reaches, this composition is a head-scratcher. It's as if 3i Atlas hails from a realm with rules we haven't yet deciphered its makeup, a recipe that defies the cookbook of cosmic formation. We must pause here for scientific rigor. The allure of extraordinary conclusions, whispers of artificiality or alien design must be tempered by caution. Nature can be a trickster, conjuring strange ratios through processes we've yet to fully grasp. Solar heating might selectively vaporize certain compounds, or a peculiar formation history could yield an oddball chemistry. A single anomalous reading, even one as striking as this, doesn't instantly prove a crafted origin. The scientific method demands skepticism, urging us to exhaust natural explanations before leaping to the extraordinary. Yet, an analogy sharpens the stakes. Imagine sifting through a pile of meteorites, each bearing the expected scars of cosmic chaos, only to stumble upon a fragment gleaming with the hallmarks of a spaceship-grade alloy, a high-nickel composite forged under industrial conditions. You wouldn't dismiss it as just another rock. You'd probe deeper, questioning its origins, its purpose, and whether it truly belongs among the natural debris. This metallic anomaly casts the silence surrounding 3I Atlas in a new light. If its composition indeed deviates so starkly from natural norms, the response from NASA, ESA, and other observatories makes chilling sense. Data from Psyche, HiRISE or TGO, each poised to capture high-resolution details, wouldn't be treated as routine. Such a discovery could trigger special review protocols, convene scientific committees, or even prompt classification if the implications veer into sensitive territory. This isn't conspiracy, it's procedure. Institutions built on rigor don't shrug off anomalies that challenge foundational categories. They scrutinize, gatekeep, and deliberate. The absence of Psyche's images, the embargo on TGO's data until April 2026, the missing high-rise frames all align with the scenario where 3I Atlas's composition raised red flags too bright to ignore. The blind spot here is critical. If 3I Atlas harbors a chemistry akin to industrial alloys nickel without iron paired with a CO2-rich coma, then the silence isn't sloppy oversight. It's deliberate curation. It suggests that what lies within this object, whether in its spectra or its unseen images, is too disruptive to funnel through standard channels. The question now isn't just what 3I Atlas is, but why its data is locked away. Could it be that someone somewhere glimpsed a signature too extraordinary to release a hint of something not just alien in origin, but engineered with intent? The industrial alloy mystery doesn't just deepen the enigma. It demands we ask whether we're staring at a comet or something far more profound, veiled by silence for reasons we can only begin to imagine. Part 9, Coordinated Censorship. The idea that multiple space agencies, NASA, ESA, and others might be orchestrating a concerted effort to suppress or delay data about 3I Atlas could at first glance sound like the fevered architecture of paranoia. It evokes shadowy cabals, clandestine memos, and decisions sealed in windowless rooms. Yet when we set aside knee-jerk skepticism and trace the timeline with clear-eyed precision, a subtler, more troubling pattern emerges. Not the stuff of conspiracy thrillers, but the quiet language of institutional caution. A choreography of hesitation that transcends coincidence and hints at design. NASA and the European Space Agency operate under vastly different banners, one tethered to Washington's political machinery. The other, a coalition of European nations often at odds over budgets and priorities. Their institutional DNA funding governance culture should breed divergence, not harmony. Yet as we map the saga of 3I Atlas, their actions converge in a shared rhythm of silence, delay, and obfuscation. It's as if two orchestras playing distinct scores in separate halls struck the same dissonant chord at the same precise moment. This isn't lockstep conspiracy. It's a pattern too consistent to dismiss as mere bureaucratic noise. History offers a sobering lens. The Galileo mission of the 1990s sent back images of Jupiter's moons that upended assumptions about those icy worlds. Yet some data was held back, filtered through cautious channels, released in measured drips. The Apollo program, humanity's crowning leap, locked away hours of audio and telemetry for decades, only pried loose by persistent researchers. During the Cold War, reconnaissance satellites circled Earth, their advanced optics capturing secrets that dwarfed civilian science unknown to the public until declassification peeled back the veil years later. These weren't accidents. They were protocols activated for data deemed too potent, too disruptive for immediate release. The frameworks are mundane, not exotic national security, where an object like 3I Atlas could imply technological or defensive implications. Planetary protection, where even a whiff of biological or material risk triggers silence. International coordination, where aligned embargoes prevent diplomatic chaos. Or mission priorities, where proprietary data access creates natural delays. Each could explain a pause, innocent, procedural, expected. But here's the rub: comets don't typically trigger these protocols. NASA's Hubble Space Telescope has snapped countless comet portraits, flooding archives with minimal delay. The James Webb Space Telescope, despite its exquisite sensitivity, shares its cosmic vistas within weeks. ESA's Rosetta mission orbiting Comet 67P streamed images in near real time, inviting the world to witness discovery unfold. Comets are science's open book, shared eagerly, dissected publicly. So why does 3I Atlas break this mold? Why does this interstellar visitor provoke silences where floods of imagery should flow? The timeline is our witness, and its coincidences verge on choreography. In early September 2025, NASA's Psyche spacecraft goes dark for 5 critical days, its archive barren during the prime window, to observe 3I Atlas. No images, no explanations, just a void where high-resolution data was expected. Days later, ESA's ExoMars Trace Gas Orbiter stumbles into its own anomaly, a bizarre 2099 release date for its data, later revised to April 3, 2026. A lockbox months away, far beyond the norm for comet observations. Meanwhile, NASA's high-rise camera orbiting Mars with the power to resolve 3I Atlas's nucleus in stunning detail yields nothing: no images, no status updates, no acknowledgement. One agency's silence could be a glitch. 2 might be inertia. 3 or more, aligned in their reticence, begin to resemble intent. Skeptics will argue that bureaucracy alone explains this: glitches, cluster delays, compound systems falter. They're not wrong. Institutions are messy. But those who've studied their rhythms know that accidents often gather around moments of unease. When systems encounter anomalies they can't neatly process. The data droughts surrounding 3I Atlas, Psyche's Blackout, TGO's embargo, high-rises' absence aren't random. They cluster around an object that defies every cometary norm: a Sunward Jet, a nickel-rich composition bereft of iron, a carbon dioxide coma, a geometric halo. These aren't just quirks. They're signatures that challenge the label of comet. No smoking gun exists, no leaked NASA memo, no ESA whistleblower confessing to a cover-up. What we have is a constellation of suspicious timings, a pattern that rhymes across missions and continents. If 3I Atlas were a standard comet, a simple rock, there'd be no cause for hesitation. The very existence of suppression, coordinated or not, implies something extraordinary, an object that doesn't fit, that triggers protocols reserved for the unknown. What could justify such silence? A machine, perhaps a probe harvesting solar energy, a relic of a civilization that seeded the stars long before humanity's first spark, or something stranger, blurring the line between natural and artificial. The silences aren't absence, they're signal. They're the sound of institutions grappling with a truth too vast to share without preparation. The Sunward Jet, the industrial alloy-like composition, the missing images, they point to something that unsettles the familiar narrative of just another comet. As the timeline locks into place, it suggests not chaos but choreography, a deliberate dance to shield a discovery that could redefine our place in the cosmos. 3I Atlas isn't just an object, it's a question, and the silence surrounding it is an answer we're not yet permitted to hear. Part 10. The Sun Machine Hypothesis. The myriad threads of this cosmic mystery. 3I Atlas's baffling anomalies, the inexplicable gaps in data, the synchronized silences from the world's premier space agencies, now weave together into a single electrifying question that has haunted every revelation, every missing image, every institutional hesitation. What if 3I Atlas isn't a comet at all? Not a mere fragment of frozen debris tumbling aimlessly through the interstellar void, but a machine, a probe, a construct of deliberate intelligence engineered to harness our sun's radiant energy for propulsion, navigation, or some purpose beyond our current comprehension. At first blush, the idea feels audacious, teetering on the precipice of science fiction, conjuring visions of alien technology in a field where scientists cling to the familiar comfort of natural explanations. Yet, audacity isn't error. This hypothesis demands a seat at the table, not because it's proven, but because it gathers the scattered fragments of anomaly into a coherent pattern, where conventional frameworks buckle under the weight of contradiction. Like a key sliding into a lock, the notion of an artificial probe explains more with fewer contortions, while naturalistic models strain to bridge the widening gaps. The cornerstone of this enigma is a single defiant image released with clinical precision on October 16, 2025, yet landing like a thunderbolt in the astronomical community. The photograph captures a jet of material erupting from 3I Atlas, not streaming away from the sun as the immutable laws of cometary physics demand, but toward it. For a comet, this is nothing short of cosmic blasphemy. The thermodynamics of sublimation are clear solar radiation heats, a comet's icy core transforming volatiles into gas that bursts outward, carried by momentum and sculpted by the sun's radiation pressure, into tails that always arc away from the star. This is the elegant ballet of comets, choreographed by heat pressure and light, a law as fundamental as gravity's pull on a falling stone. Yet 3I Atlas defies this script, its Sunward Jet, a bold middle finger to expectation. As a natural phenomenon, it's a head-scratcher, a plume that laughs at thermodynamics. But as the exhaust of a machine, it clicks into place. Envision a probe firing thrusters, venting ionized material in controlled bursts to adjust its trajectory as it approaches perihelion, the sun's fiery embrace. The anomaly transforms into a maneuver. the inexplicable becomes a calculated act of navigation, and the physics align with startling clarity. This Sunward Jet is just the opening note in a symphony of oddities. Layer it against the spectroscopic data, which reveals a nickel-rich outgassing conspicuously devoid of iron, a composition that reads less like a product of stellar forges and more like an industrial alloy akin to humanity's Inconel, engineered for extreme durability. In nature, nickel and iron are cosmic twins forged together in the hearts of stars and entwined in meteorites, asteroids, and planetary cores. Separating them requires processes, energy refinement that mirror industrial metallurgy, not the chaotic churn of interstellar dust. Why would a random cosmic body bear such a signature unless it had been deliberately processed? Then there's the carbon dioxide heavy coma detected by the James Webb Space Telescope, which clashes with the water ice and volatile-rich shrouds of typical comets. This CO2 dominance points to formation near the carbon dioxide ice line, a niche environment far removed from the Oort cloud or interstellar origins we'd expect. Add to this the Space Invader-shaped halo with its geometric edges and structured form observed in specific wavelengths, a feature that suggests not a natural coma of dust and gas, but a plasma field or electromagnetic shield, actively generated by the object itself. These aren't isolated quirks. They're puzzle pieces that snap together only when we entertain the possibility of design. The institutional silences amplify this pattern. NASA's Psyche spacecraft, armed with cameras capable of resolving metallic surfaces in exquisite detail, went dark for 5 critical days in September 2025, its archive barren during the prime window to observe 3I Atlas. No images, no explanations, just a void where clarity was expected. ESA's ExoMars Trace Gas Orbiter, poised to capture spectral and imaging data during the object's Martian flyby, locked its findings behind a bizarre 2099 placeholder, later revised to an April 2026 release, a delay that defies the norm for comet data. The Mars Reconnaissance Orbiter's high-rise camera, with its 30-centimeter resolution, should have delivered breathtaking portraits of 3I Atlas's nucleus. Yet no frames have surfaced, no status updates offered. These aren't random glitches. They're a coordinated pattern of absence, a choreography of restraint across agencies and continents. Individually, each anomaly might stretch natural models to their breaking point. Together, they form a constellation that points to something beyond a comet, a machine perhaps, with a purpose we can only guess. The analogy to human technology is inescapable. We've already dipped our toes into solar sails, spacecraft propelled not by chemical fuel, but by the gentle push of stellar photons. NASA has funded prototypes and research thrives on the mechanics of light-driven propulsion. If humanity, barely a fledgling in cosmic terms, can harness stellar energy, why is it unthinkable that a civilization older, wiser, or simply more patient might deploy such systems across galactic distances? A probe designed to graze stars for power could explain the Sunward Jet, a thruster firing to stabilize its course during a solar pass. The geometric halo might be a plasma shield deflecting cosmic rays, or solar wind to protect delicate systems. The nickel-heavy, iron-free composition could reflect engineered materials crafted for resilience in the harsh void. The CO2-rich coma might even suggest exhaust or thermal regulation, not a natural ice reservoir. This isn't wild speculation. It's a model that fits the data grounded in principles we already explore. Consider a bolder leap. Physicists have long mused about Dyson swarms, vast arrays of structures orbiting stars to harvest their energy. What if 3I Atlas is a fragment of such infrastructure? A scout, a sensor, a component tasked with collecting data or reporting back to an unseen network, or perhaps it's simpler, a vessel venting excess heat or waste material sunward to maintain equilibrium its jet, a routine maintenance tick in a system far beyond our grasp. These scenarios, while outside mainstream consensus, aren't falsified by the evidence. They require only a shift in perspective, a willingness to see intent where we've assumed randomness. Skeptics, as they must, push back. Comets are notoriously erratic, they argue. Jets can twist in odd directions due to rotational dynamics or uneven outgassing. Chemical anomalies might stem from rare formation conditions or solar heating quirks. The halo could be a natural plasma distortion, not a shield. Peer-reviewed journals caution against pattern seeking, urging us to exhaust mundane explanations before chasing the extraordinary. This is science's strength, its rigor, its demand for restraint. But rigor can calcify into dogma. Dismissing anomalies as mere oddities risks blinding us to breakthroughs. Copernicus upended the heavens because the Ptolemaic model failed to explain the stars. Darwin reshaped biology because fossils and finches demanded a new story. Science advances when anomalies force us to rethink categories, and 3I Atlas, with its cascade of contradictions, may be such a catalyst. 3 possibilities crystallize. First, 3I Atlas is a natural body, an eccentric comet whose peculiarities, however extreme, still fit within physics' elastic bounds. Second, it's a probe, an artifact of intelligence, whether a forgotten human relic or an alien emissary. Third, it's a hybrid, something liminal, where natural and artificial blur, a comet adapted or engineered into service its behaviors, mimicking technology in ways that collapse our distinctions. If natural, it expands cometary science, teaching us humility. If artificial, it's a seismic shift proof that interstellar technology has grazed our doorstep. If hybrid, it's the most unsettling of phenomenon that defies our binary of rock versus machine, hinting at realities we can't yet pass. The institutional silence, Psyche's Blackout, Tigio's logbox, High-Rise's absence takes on new weight in this light. If 3I Atlas is a machine, the response makes grim sense. Such a discovery would trigger immediate classification, pulling data behind walls of secrecy. National security protocols would flare. Planetary protection concerns would demand caution, and international coordination would enforce synchronized restraint. Agencies wouldn't rush to proclaim a paradigm shift. They'd retreat to committees, deliberating how to frame a truth that could spark wonder, fear, or chaos. The silence isn't a glitch. It's a shield, guarding a revelation too vast for unprepared minds. 3I Atlas isn't just an object. It's a challenge to our science, our institutions, our courage. Its Sunward Jet alloy-like composition, structured halo, and the deafening quiet surrounding it suggest not a comet, but a construct, a sun machine, perhaps harvesting stellar energy for a purpose we can only imagine. If true humanity has already been visited, already been seen, the question is whether we'll open our eyes to the evidence or cling to the comfort of icy debris. The stars have sent a messenger, and its silence roars louder than any tale. Our choice is simple: demand, transparency, and face the truth, or let the institutions decide what we're ready to know. History has turned. The only uncertainty is whether we'll turn with it. Part 11. Europa Clipper's imminent window. As 3I Atlas carves its fiery arc toward the sun before hurtling back into the interstellar abyss, another spacecraft far from Earth's gaze aligns with a moment of profound consequence. NASA's Europa Clipper mission, a beacon of astrobiology in the 2020s, is no longer a distant aspiration confined to blueprints and proposals. It has arrived at a pivotal juncture. Launched to probe the hidden oceans beneath Europa's icy crust, this mission carries humanity's boldest question: could life thrive in the shrouded seas of Jupiter's enigmatic moon? But as late October 2025 dawns, Europa Clipper is more than a scientific envoy. It's a sentinel at the edge of the solar system, equipped with instruments so advanced they transcend their stated purpose. Its imminent observation window, perfectly timed with 3I Atlas's solar passage, raises a possibility as thrilling as it is unsettling. What if this mission, branded for astrobiology, captures something far beyond Europa's frozen frontier? Europa Clipper's arsenal is a marvel of engineering. Its ice-penetrating radar, designed to peer through kilometers of frozen crust, can map subsurface oceans with unprecedented clarity. Its high-resolution imaging arrays, built to capture Europa's fractured ridges and chaotic terrains in exquisite detail, rival the finest telescopes humanity has ever wielded. Its spectrometers, tuned to sniff out the chemical signatures of habitability, can dissect the composition of distant objects with surgical precision. These tools, while crafted for Europa, are agnostic. They bend light capture photons and register anomalies, regardless of their target. In the vast, unmonitored corridors of space, intention is malleable. A radar meant for ice can scan the heavens. A camera aimed at a moon can pivot to an interstellar visitor. A sensor built for chemistry can probe the composition of something streaking through the void. Europa Clipper, stationed in Jupiter's orbit, occupies a vantage point unmatched by Earthbound observatories, with a clear line of sight across regions of the solar system obscured from our planet's view. It's not just a mission. It's a cosmic lookout, perfectly positioned to observe 3I Atlas if its handlers choose to redirect its gaze. This duality transforms Europa Clipper from a focused exploration into something far grander and more disquieting. The analogy is stark, even brutal. A defense radar built to track missiles can double as a surveillance tool. A weather satellite monitoring clouds can capture images of military bases. Instruments once built are promiscuous. They serve any purpose their capabilities allow. Europa Clipper is no exception. Its radar could probe the structure of a passing object, like 3I Atlas, revealing whether its nucleus is a chaotic lump or something eerily geometric. Its cameras could snap images sharp enough to discern edges, angles, or unnatural forms. Its spectrometers could confirm or refute the nickel-heavy, iron-free outgassing or the carbon dioxide-rich coma that defy cometry norms. From Jupiter's orbit, Clipper is a silent sentinel capable of witnessing cosmic traffic that Earth's telescopes might miss. The question isn't whether it can observe 3I Atlas. It's whether it will, and whether we'll ever see what it finds. The precedent is sobering. 3I Atlas has already taught us what happens when an anomalous visitor enters our solar system. NASA's Psyche mission, poised to capture high-resolution images in September 2025, went dark for 5 critical days, its archive barren during the object's prime observation window. No explanation, no data, just silence. The US government shutdown in October was a convenient scapegoat, but the timeline betrays it. The blackout preceded the budget chaos by weeks. ESA's ExoMars Trace gas orbiter, which grazed 3I Atlas during its Martian flyby, locked its data behind a bizarre 2089 placeholder, later revised to April 2026, a delay that mocks the open science ethos. The Mars Reconnaissance Orbiter's high-rise camera, capable of resolving details as small as 30 centimeters, should have delivered breathtaking portraits of the object's nucleus. Yet no images have surfaced, no updates offered. These aren't isolated glitches. They're a pattern of institutional restraint, a choreography of silence that suggests a controlled narrative. Now, as Europa Clipper enters its critical phase in late October 2025, we stand at the threshold of the next act. Will it reinforce this pattern or break it? History offers clues, and they are not encouraging. When the Cassini mission detected water plumes erupting from Saturn's moon Enceladus, a discovery that redefined our understanding of habitable worlds, the data didn't flood public archives immediately. It passed through layers of institutional scrutiny committees, reviews, cautious calibrations before reaching the world weeks later. That was for water vapor, a phenomenon firmly within natural science. What if Europa Clipper's instruments capture something far stranger? A Sunward Jet, a geometric halo, a composition that echoes industrial alloys rather than cosmic debris. If the data hints at an engineered object, a probe or a relic of intelligence, would it see daylight? Or would it vanish into classified vaults, joining the silent ranks of Psyche's missing frames and TGO's embargoed spectra? The stakes are immense, stretching beyond science into politics, security, and philosophy. Europa Clipper's public narrative is pristine, a quest to probe Europa's oceans, to map its icy crust, to hunt for signs of microbial life. Press releases will likely dazzle with images of Europa's ridges, fractures, and chaotic terrains, paired with findings on its chemistry and geology. But behind this polished facade, the spacecraft is a sentinel with a broader view. Its instruments don't care about mission mandates, they detect whatever falls within their range. From Jupiter's orbit, Clipper could register 3I Atlas's trajectory, its anomalous behaviors, or even signals that defy natural explanation. The decision lies not with the hardware, but with those who gatekeep the data. Will NASA share the full stream, or will it filter, redact, or delay, echoing the silences we've already seen? The convergence of Clipper's window with 3I Atlas's solar passage is too precise to ignore a cosmic coincidence that feels almost orchestrated. This isn't conspiracy in the Hollywood sense. It's institutional logic, bureaucratic, and human. Agencies protect narratives, control releases, and weigh the risks of destabilizing discoveries. When data threatens to upend paradigms, whether it's a plume on Enceladus or a jet on 3I Atlas, it's quarantined, passed by committees, and released only when deemed safe. If Clipper captures something extraordinary, an image of a structured object, a spectrum suggesting artificiality, a signal that doesn't fit, it could trigger protocols far beyond science national security reviews, planetary protection assessments, or international coordination to prevent diplomatic chaos. The silence wouldn't be malicious. It would be procedural, a reflex to manage a truth too vast for immediate disclosure. Europa Clipper stands at a crossroads. It's not just a mission to Europa. It's a node in a growing surveillance network, a silent witness to the solar system's mysteries. As 3I Atlas blazes past the sun, radiating anomalies, a Sunward Jet, a nickel-rich composition, a geometric halo clipper orbits into history, carrying the potential to confirm or deepen the enigma. Will its data flow freely, or will it join the growing vault of withheld truths? The universe doesn't parcel out its secrets neatly, one mission at a time. Discoveries lurk in the margins, on the edges of frames, in unexpected signals, in anomalies no budget foresaw. Clipper could find life beneath Europa's ice, or it could detect something else entirely, a machine, a probe, a relic that forces us to rethink 3I Atlas and our place in the cosmos. The choice isn't in the instruments, it's in the silence that follows. As October's window closes, we wait to see if Europa Clipper will pierce the veil or add another layer to the mystery. Part 12. Hera Mission, Planetary Defense or Planetary Surveillance. In the closing months of 2025, as the cosmic drama of 3I Atlas fades into the outer solar system's deepening shadows, a new player takes center stage in Europe's ambitious space agenda. The European Space Agency ESA has unveiled its Hera mission, slated for launch in October 2024, aboard a SpaceX Falcon 9 rocket from Cape Canaveral, with preparations accelerating in laboratories across the continent and in the hushed corridors of institutional power, where priorities are quietly reshaped. Officially, Hera is a beacon of planetary defense, a spacecraft designed to rendezvous with the Didymos binary asteroid system in late 2026, 4 years after NASA's DART mission slammed into the smaller moonlet Dimorphos in a groundbreaking test of kinetic impact deflection. Hera's mandate is straightforward: to meticulously chart Dimorphos's altered orbit, quantify the momentum transfer from DART's high-speed collision, and refine our arsenal against potential Earth-threatening asteroids. It's a mission framed in heroic terms, a proactive shield against the indifferent violence of the cosmos. On the surface, this rationale is unassailable and profoundly reassuring. Earth resides in a galactic shooting gallery pelted by rocks and ice from the void throughout its turbulent history. The Chicxulub impact 66 million years ago, a colossal asteroid carving a 180-kilometer-wide crater in Mexico's Yucatan Peninsula, didn't just extinguish the dinosaurs. It unleashed global firestorms, acid rain, and a nuclear winter that reshaped ecosystems, paving the way for mammalian dominance and ultimately humanity's rise. Such cataclysms aren't ancient footnotes. They're stark reminders of existential peril. Near-Earth objects, NEOs like Didymos, an Apollo-type rocky asteroid with a perihelion just shy of Earth's orbit, pose real risks. With up to 30,000 undiscovered asteroids, the size of Dimorphos, capable of city-killing devastation. The billions poured into missions like Hera represent cosmic insurance, early detection, precise deflection, a buffer against a universe that couldn't care less about our fragile blue marble. Yet, as with so many grand space endeavors, the polished press releases and inspirational visuals obscure a more intricate and arguably more ominous reality. Hera isn't just a defender, it's a watcher. Its suite of instruments, crafted for exquisite precision, includes 2 asteroid framing cameras, AFC for high-resolution optical imaging, a thermal infrared imager, TIRI for surface mapping. a Hyperscout H hyperspectral imager for mineralogical analysis, a planetary altimeter, PALT laser radar for topographic profiling, and the radio science experiment RSE, leveraging the spacecraft's high-gain antenna for gravity field measurements. These tools, developed by consortia like Jena Optronic in Germany and TSD Space in Italy, are tuned to detect subtle shifts in trajectories, tiny surface fragments, and delicate structural features on targets millions of kilometers distant. They will enable Hera to orbit Didymos at altitudes as low as 20 kilometers, mapping Dimorphos's crater down to decimeter resolution, and probing the binary system's internal dynamics with unprecedented fidelity. But here's the crux. These sensors don't deactivate once Hera departs the Didymos system. The same LiDAR that etches asteroid topography can scan incoming trajectories across interplanetary space. The optical cameras that dissect rubble piles can pivot to scrutinize anomalous visitors streaking through the inner solar system. The hyperspectral imager, designed to sniff out carbon-rich compositions on Dimorphos, could dissect the chemical signatures of something far stranger, an interstellar interloper like 3I Atlas with its nickel-heavy iron-free outgassing or carbon dioxide-dominated coma. In essence, Hera embodies the inescapable dual-use principle that shadows all advanced technology. A system built for defense inevitably doubles as a tool for surveillance. Radars meant to track missiles monitor civilian flights. Weather satellites capture troop movements alongside storm fronts. Hera's capacity to detect and characterize NEOs extends seamlessly to monitoring anything extraordinary, be it a comet with a Sunward Jet or a probe-like object defying gravitational norms. This duality isn't accidental. It's baked into the architecture of innovation. Consider the Cold War's early warning radars, justified as bulwarks against nuclear Armageddon, which quietly evolved into global surveillance webs, tracking not just warheads, but atmospheric tests, satellite launches, and orbital clutter. Hera follows this trajectory. Publicly, its planetary defense validating kinetic impacts, modeling asteroid deflection for future threats. Beneath that veneer, it fortifies a shadow network for planetary surveillance, a sentinel scanning for interstellar anomalies, visitors that blur the line between natural and artificial. In the wake of Oumuamua's 2017 flyby, with its non-gravitational acceleration and cigar-shaped enigma, and 3I Atlas's cascade of oddities, unusual spectroscopic emissions, an anti-tail twisting against expectations, a geometric space invader-shaped halo. The need for such vigilance feels prescient. These objects don't fit neatly into asteroid or comet categories. They accelerate inexplicably, emit rare chemical pairings, and produce jets from improbable angles. The institutional patterns we've traced only heighten the unease. When 3I Atlas skimmed Mars in early October 2025, orbiters like NASA's Mars Reconnaissance Orbiter with its high-rise camera resolving 30-centimeter details, and ESA's ExoMars Trace Gas Orbiter were ideally positioned for high-fidelity captures. Yet only sanitized anomaly-free images trickled out while raw data vanished into delays or outright absence. NASA's Psyche probe primed for September 2025. Imaging plunged into a 5-day blackout, its archives silent during the critical window, weeks before the US government shutdown could plausibly excuse it. Ground-based telescopes, later unveiled the Sunward Jet on October 16th, a propulsion-like plume that mocks cometary physics. If agencies already gatekeep ordinary anomalies, what faith can we place in Hera's transparency? Its data funneled through ESA's European Space Operations Center. ESOC in Darmstadt will pass through the same protocols: filtered reviews, calibrated releases, institutional layers that prioritize safe narratives over unvarnished truth. If Hera detects something anomalous, a non-natural trajectory, a metallic signature echoing industrial alloys, a structured emission hinting at artificial intent, the outcome won't be a press conference fireworks display. It will likely trigger classified reviews, perhaps under the auspices of ESA's Near-Earth Object Coordination Center, NEOCC, or international collaborations like the Asteroid Impact and Deflection Assessment, AIDA. The template was set by Oumuamua and 3I Atlas Hesitation Delays Selective Silence. Ethical questions loom large. Taxpayers fund Hera $363,398 in ESA commitments under the banner of planetary protection. Shouldn't they know it doubles as a cosmic watchdog scanning for interstellar oddities? What protocols govern a detection of unambiguous artificiality? A machine harvesting solar energy, a relic blurring natural and engineered boundaries. The refusal to air these debates doesn't dissolve them. It consigns them to backrooms where unelected committees decide the public's cosmic literacy. This silence stems not from malice, but from bureaucratic gravity, an inexorable pull toward control. Institutions evolve, monitoring begets scrutiny. Data streams spawn analysis, anomalies, birth protocols. What starts as deflection testing morphs into comprehensive surveillance, then anomaly detection, and finally, information curation. Hera's 2 CubeSats Juventus, with its low-frequency radar for internal sounding, a scaled-down Rosetta Legacy, and Milani with its aspect hyperspectral imager and Vista thermogravimeter for dust and volatile analysis amplify this. Deployed near Dimorphos, they'll probe subsurface structures and ejector plumes, but their inter-satellite links and autonomous navigation could extend to tracking transient visitors. Hera's arrival in November 2026, a month ahead of schedule thanks to efficient propulsion and Mars flyby tweaks, symbolizes this shift from passive stargazing to active interception. As 2025 wanes and 3I Atlas recedes, Hera's ramp-up feels emblematic. One visitor exits as the next Sentinel launches, heralding an era where science and security entwine. We're no longer mere observers. We're architects of orbital patrols, building fleets to intercept, measure, and guard. Yet, transparency lacks. The agencies that muted Psyche's feed and curated Mars flyby images will likely gloss Hera's outputs, orbital efficiency metrics, rubble pile models, surface compositions. Anomalies. A synthetic signal, an engineered plume, will slip into classified streams dissected by panels whose whispers never reach the public square. This isn't individual conspiracy, it's structural evolution. As tools sharpen, applications broaden. As oddities proliferate, silences thicken. Hera isn't just a mission, it's a milestone bridging planetary defense and surveillance exploration and enclosure. The real peril public discourse can't match institutional agility. We'll celebrate glossy Didymos close-ups, while deeper truths, jets that defy physics compositions, that whisper design languish in vaults. Hera arrives amid 3I Atlas's echo, a sunward machine perhaps, or a natural freak. Either way, it underscores our vulnerability not to asteroids, but to the gatekeepers who curate our view of the stars. As 2025 closes with Hera's integration tests underway at ESA's ESTEC in Nordvik, the question isn't whether it will succeed. It's whether we'll glimpse its full harvest, or only the harvest they deem safe. The universe doesn't whisper. Our institutions do. And in that gap lies the true cosmic threat. Part 13. AI in Space Science, the Hidden Reviewer. As 2025 unfolds, the astronomical community finds itself swept up in a tidal wave of data, a deluge pouring from telescopes and spacecraft that threatens to overwhelm human capacity. The James Webb Space Telescope, JWST alone, generates terabytes of raw imagery and spectroscopy, daily capturing cosmic vistas with unprecedented clarity. Add to this the steady streams from Hubble's aging but still vigilant optics, Chandra's X-ray probes, ESA's Gaia, mapping the galaxy's stars, the Vera C. Rubin Observatory's ground-based surveys poised to scan the entire sky every few nights, and planetary missions like Psyche Europa Clipper and Mars orbiters like the Mars Reconnaissance Orbiter MRO. The result is a fire hose of information, petabytes of pixels, spectra, and telemetry that no team of researchers could manually sift through in a lifetime. To survive this flood, astronomers have turned to artificial intelligence AI and machine learning ML tools that have become the unsung gatekeepers of modern space science. These systems aren't just aids. They're the first eyes on the cosmos, triaging, filtering, and categorizing data before a human ever glimpses it. But this reliance on automation, while essential, casts a shadow over the saga of 3I Atlas, raising a question as critical as it is overlooked. What happens when the algorithms themselves decide what's too strange to share? AI's role in astronomy is both revolutionary and pragmatic. Modern observatories produce data at a scale that defies human processing. JWST's near-infrared camera NearCam alone can generate 100 gigabytes per observation, while the Vera Rubin Observatory's 3.2 gigapixel camera is expected to churn out 20 terabytes nightly once fully operational. Without automation, researchers would drown in noise, cosmic rays, instrument glitches, and redundant frames clogging the pipeline. AI steps in as a filter organizer and triage nurse trained on vast datasets to recognize normal patterns, the spectral signatures of comets, the orbital arcs of asteroids, the light curves of stars. When data aligns with these expectations, it flows smoothly into public archives, like NASA's Mikulski Archive for Space Telescopes, or ESA's Planetary Science Archive. But when it deviates, when it screams anomaly, the system doesn't discard it. It does something subtler and far more consequential. It flags it, reroutes it, or locks it into a limbo of pending verification. This is where the story of 3I Atlas collides with the hidden machinery of modern science. Consider the mechanics. AI models like those built on convolutional neural networks or anomaly detection algorithms are trained on historical data comet spectra, rich in water ice and silicates asteroid orbits, governed by Newtonian mechanics jets, driven by solar sublimation. When Psyche's cameras or ExoMars's spectrometers captured 3I Atlas with its Sunward Jet defying cometary physics, its nickel-heavy iron-free outgassing, or its non-gravitational acceleration, these traits would have lit up the algorithms like warning flares. They don't fit the training sets. a jet streaming toward the sun. Outside the sublimation model, nickel without iron alien to natural metallurgy. A carbon dioxide-dominated coma, inconsistent with Oort cloud or interstellar origins. The space invader-shaped halo with its geometric edges, unlike any natural plasma distortion. Each anomaly would trigger a flag diverting the data from the public stream into a review pipeline, first algorithmic, then human. This isn't conspiracy. It's protocol baked into the system's design to filter out noise and protect science from false positives. But here lies the paradox. What if the anomaly isn't noise but a genuine breakthrough? What if 3I Atlas's peculiarities, its propulsion-like jet, its alloy-like composition, its structured halo, are the signatures of something revolutionary, like a non-human probe? Algorithms bound by their training can't distinguish between instrument error and paradigm-shifting novelty. They only know this doesn't fit. A Sunward Jet might be tagged as a telemetry glitch. A nickel anomaly might be flagged as sensor noise. Once rerouted, the data enters institutional limbo where human gatekeepers, mission scientists, review boards, agency officials decide its fate. Do they release it immediately, risking misinterpretation? Hold it for extended analysis, citing calibration needs? Or if the implications are too seismic, divert it into classified channels? The silence surrounding Psyche's 5-day blackout in September 2025, precisely when it should have imaged 3I Atlas, begins to look less like a technical hiccup and more like a data stream shunted into quarantine. The absence of high-rise images from Mars, the embargoed ExoMars data until April 2026, these align with a system where anomalies are flagged, held and scrutinized, not shared. This isn't malice, it's structural. AI-driven anomaly detection is a double-edged sword honed by necessity, but wielded with unintended consequences. In medical imaging, AI flags tumors in MRIs, saving lives by catching what humans miss. In cybersecurity, it spots network intrusions before they escalate. In astronomy, it weeds out cosmic rays and corrupted pixels, ensuring exoplanets or supernovae aren't mistaken for artifacts. But when the anomaly is the discovery itself, when it's the first hint of a machine traversing our solar system, the system risks suppressing the very truths it's meant to uncover. The training data sets built on decades of normal comets and asteroids are blind to phenomena outside those bounds. A probe mimicking a comet with engineered jets or synthetic materials would register as error, not evidence. The more sophisticated our filters, the more they become novelty suppression engines, catching the frontier of discovery in their nets and routing it away from public view. Layer on the institutional psychology and the stakes climb higher. NASA and ESA operate under intense scrutiny, political, budgetary, cultural. A misstep can spark ridicule, defunding, or sensational headlines. Data that's too strange, say a spectrum suggesting artificial alloys or an image hinting at geometric structure, carries risks, public panic, media frenzy, or accusations of scientific overreach. Agencies have learned to hedge curating releases to avoid embarrassment. The 1996 ALH-84001 meteorite, with its tantalizing hints of Martian microfossils, sparked a media storm that NASA later struggled to temper. 3I Atlas, with its cascade of anomalies, could ignite something far larger. If Psyche's missing images or ExoMars' delayed spectra contain evidence of non-natural origins, the cautious path isn't disclosure, it's containment analysis, and controlled narrative crafting. This dynamic reshapes the scandal of 3I Atlas. Psyche's Blackout from September 1st to 5th, 2025 isn't just a glitch. It's a symptom of a system where AI flags anomalies and humans wary of the implications hold them back. The absence of HiRise's Martian images, the 2099 placeholder for ExoMars data, the silence from Europa Clipper's looming window all point to a pipeline where novelty is quarantined, not celebrated. This isn't about one mission or one object. It's about the future of discovery itself. Astronomy in 2025 isn't the open frontier of 2005, when raw telescope data flowed directly to researchers' anomalies and all. Today, AI gatekeepers decide what's normal enough to share, and institutional discretion buries what isn't. The infrastructure of exploration has, without public debate, become an infrastructure of control. History reminds us that breakthroughs are born from anomalies. Radioactivity was a photographic plate's unexplained fog until Marie Curie unraveled its secrets. Quasars were radio noise until they unveiled black holes. Dark matter emerged from galactic rotation curves that defied prediction. Each leap began with data that didn't fit data someone chose to pursue, not suppress. 3I Atlas, with its Sunward Jet alien chemistry and geometric halo, may be such an anomaly, a signal of something beyond comets, perhaps a probe or a hybrid defying our categories. If our algorithms and institutions filter it into oblivion, we risk not just missing a discovery, but shrinking our cosmic vision to the boundaries of what we already know. The true scandal isn't Psyche's missing days or ExoMars' lockbox. It's that we've built a system where anomalies vanish by design, not conspiracy, but code. Science thrives when its strangest surprises are let into the light. If we let AI and bureaucracy gatekeep the unknown, we'll see the cosmos through a narrowing lens, discovering only what fits our expectations. 3I Atlas challenges us to demand more, to question the filters, to insist on transparency, to embrace the anomalies that could redefine our place among the stars. The universe is speaking. The question is whether we've programmed ourselves to listen. Part 14. The New Physics Rumblings. In the scientific literature of 2025, a quiet but seismic shift is stirring whispers of novel physics that transcend the incremental tweaks of orbital mechanics or refined coefficients in familiar equations. These aren't mere adjustments to existing models. They're tremors hinting at a fundamental rupture in our understanding of the cosmos. At the epicenter lies 3I Atlas, an interstellar interloper whose behavior mocks the tidy frameworks of cometary science, challenging the very laws we thought governed the heavens. From the earliest high-resolution datasets, institutions tracking this object, NASA, ESA, and global observatories, have flagged characteristics that refuse to conform, each anomaly a crack in the edifice of textbook physics. The question isn't whether 3I Atlas is strange. It's whether its strangeness heralds a new domain of knowledge or something even more audacious. The first anomaly is deceptively simple yet profoundly unsettling: 3I Atlas's mass. Based on its observed brightness, surface area, and coma formation, astronomers expected a mass typical of a comet, a dirty snowball of volatile ices and rocky silicates, porous and lightweight, with a density akin to loosely packed snow. But the numbers betray a different story. Orbital calculations derived from tracking data by systems like JPL's Horizons suggest 3I Atlas is far denser than its size permits, as if composed of compact alloys or engineered composites rather than fragile ice. This discrepancy alone could fuel a decade of theoretical debate, forcing researchers to rethink the formation of interstellar objects. A comet this heavy implies either an alien formation process, perhaps in a denser stellar nursery, or something crafted, not coalesced. It's a puzzle that doesn't just stretch our models, it threatens to snap them. But the mass anomaly is merely the prelude. The true scandal lies in 3I Atlas's acceleration patterns, which defy the cornerstone of cometary dynamics, non-gravitational acceleration. Comets, as they approach the Sun, heat up, sublimating ices into gas jets that act like tiny thrusters, nudging their orbits in predictable ways. This effect, well documented since the days of Halley's Comet, is so routine that software like Horizons folds it into trajectory models with ease. Outgassing causes comets to wiggle against purely gravitational paths, a chaotic but calculable dance. Yet 3I Atlas doesn't dance, it marches. Its acceleration is too strong, too precise, too directional. Instead of the random, averaged-out microjets expected from sublimation, the object exhibits forces that are clean, controlled, and aligned in ways that defy thermal models. Picture a campfire, sparks and smoke swirl chaotically. Now imagine those sparks moving in lockstep, as if guided by an unseen conductor. That's the scale of strangeness here, acceleration vectors that suggest intent, not chance. Mainstream theorists have scrambled for natural explanations. Electrostatic forces born from the solar wind's charged particles interacting with a comet's dust cloud can generate subtle pushes beyond gas pressure. This is real physics observed in comets like 67P Churyumov-Gerasimenko. But the magnitude of 3I Atlas's acceleration dwarfs what solar wind typically delivers. It's like claiming a desk fan could shove a semi-truck. Another hypothesis points to radiation pressure, where sunlight's photons impart momentum to small reflective objects, as in solar sails. NASA's NEA Scout mission, launched in 2022, proved this concept with an 86 square meter sail. But comets are rough, absorptive, and tumbling, not mirrored sails, optimized for photon thrust. To explain 3I Atlas's behavior, it would need surfaces or coatings, unlike anything nature produces, specular engineered, deliberate. Each natural explanation stretches credulity, fraying the fabric of conventional models until it tears. This leads to the hypothesis astronomers whisper only in private active propulsion. What if 3I Atlas isn't a passive rock, but a vessel steering itself through our solar system? The Sunward Jet, captured in that haunting August 2025 image, transforms from a sublimation anomaly into a thruster's exhaust fired to adjust trajectory during a solar pass. The nickel-rich, iron-free composition, akin to industrial alloys like Inconel, suggests not cosmic chance but engineered materials built for high radiation environments. The carbon dioxide-heavy coma detected by JWST hints at a synthetic process, not a natural ice reservoir. The geometric space invader-shaped halo observed in specific wavelengths could be a plasma shield or propulsion byproduct, not a random dust cloud. Together, these traits paint a picture not of a comet, but of a machine, a probe perhaps navigating with purpose, harvesting solar energy or maintaining stability in ways we're only beginning to grasp. Skeptics, bound by scientific rigor, push back. Comets are notoriously erratic. Jets can erupt unpredictably. Compositions can vary, and rotational dynamics can mimic directed forces. Sky and Telescope and Nature Astronomy articles in 2025 urge caution, citing rare comets like C2017 K2 with unusual chemistries or Hale-Bopp's complex jets. Extraordinary claims, they argue, demand extraordinary evidence, and suggesting an interstellar probe is among the boldest. This conservatism is science's strength, guarding against leaps into fantasy. But caution can calcify into dogma, blinding us to data that screams for new frameworks. Copernicus faced ridicule for heliocentrism. Einstein's relativity was dismissed as absurd until experiments confirmed it. History's breakthroughs were anomalies that refused to be ignored. And 3I Atlas's behavior, its density, its acceleration, its defiance of models, may be such a signal. The institutional silences amplify the stakes. NASA's Psyche probe, slated to image 3I Atlas on September 3rd to 4th, 2025, went dark for 5 days, its raw archive empty from September 1st to 5th. The feed resumed on September 8th, but no images of the object surfaced, and no explanation bridged the gap. The October 1st US government shutdown, often cited as a scapegoat, came weeks later, exposing the blackout as unrelated. ESA's ExoMars Trace Gas Orbiter, which observed 3I Atlas during its Martian flyby, initially tagged its data with a 2099 release date, a glitch corrected to an April 3rd, 2026 embargo, still months beyond the norm. The Mars Reconnaissance Orbiter's high-rise camera, capable of resolving 30-centimeter details, has yielded no images. Europa Clipper's late October window looms, yet the pattern of delay and absence persists. These aren't random. They're a choreography of control, suggesting data too disruptive for public release. If 3I Atlas embodies novel physics or daringly engineered propulsion, these silences aren't mere bureaucracy. They're gatekeeping. Imagine if Galileo's telescope had been locked away after spotting Jupiter's moons, or if Hubble's first images of distant galaxies had been classified. The Psyche blackout, the ExoMars delay, the high-rise absence, they mirror a system where anomalies are quarantined, not celebrated. If 3I Atlas is a probe, its data could rewrite physics unveiling propulsion without fuel materials engineered for stellar environments, or navigation defying gravitational norms. If it's a natural body pushing physics boundaries, it still demands new models, perhaps a rethinking of interstellar formation or non-gravitational forces. Either way, the stakes are monumental, touching not just science, but humanity's place in the cosmos. The rumblings of new physics aren't confined to journals. They echo in the silences. Institutions wary of reputational risk or geopolitical fallout default to caution, framing anomalies as glitches or burying them in review pipelines. This isn't conspiracy, it's sociology. Large organizations shield themselves, prioritizing control over discovery, but science thrives on the anomalies they suppress. Radioactivity was a glowing rock until it birthed nuclear physics. Quasars were noise until they revealed black holes. 3I Atlas, with its heavy mass, directed acceleration, and alloy-like signatures, may be the anomaly that forces us to rewrite reality. The scandal isn't that it exists, it's that we might be looking away, choosing silence over confrontation. We stand at the edge of a cosmic forest, hearing the rustle of something vast. The question is whether we'll light a lantern and step forward, or let the gatekeepers dim the stars. Part 15. Beyond Atlas, the pattern of silence. To fully grasp the enigma of 3I Atlas, we must pull back from the singular drama of this interstellar visitor and view it as a single thread in a far grander, more troubling tapestry, a pervasive pattern of silence that has woven itself through the scientific landscape of 2025, stretching across multiple domains of research and technology. This isn't merely the story of one object's anomalies, one spacecraft's blackout, or one agency's delay. It's a systemic shift in how cutting-edge discoveries are managed, a trend that transcends astronomy to touch fusion energy, radio, astronomy, defense, aerospace, and beyond. The silences surrounding 3I Atlas, NASA's Psyche probe going dark, ESA's ExoMars data locked behind an embargo, the Mars Reconnaissance Orbiter's high-rise camera yielding no images, are not isolated mishaps. They are symptoms of a broader structural evolution in how institutions handle data that challenges established paradigms. This pattern, once recognized, reveals a chilling norm: the gatekeeping of anomalous findings, where algorithms, review boards, and classified protocols conspire to filter what reaches the public and even the wider scientific community, raising profound questions about transparency, trust, and the future of human discovery. A tapestry of suppression. Let's widen the lens. In fusion energy, 2025 has been a year of tantalizing breakthroughs. Facilities like the European Spark Project ITER's ongoing experiments in France and private ventures such as Commonwealth Fusion Systems and TAE Technologies have reported milestones. Plasma confinement times extended to seconds, energy yields creeping toward break-even, and magnetic field designs pushing the boundaries of practical fusion. These should be heralded with global fanfare, raw data flooding open repositories like the IAEA's Fusion Data Portal for collaborative analysis. Yet, the reality is starkly different. Detailed datasets lag behind vague press releases, often confined to restricted archives under the guise of review and validation protocols. For instance, Spark's 2025 tests, which achieved a Q-factor energy output versus input approaching 1, were announced with glossy summaries, but no public access to raw magnetic confinement data. The justification's calibration needs proprietary concerns or pending peer review are plausible on their surface. But their consistency across facilities, both public and private, hints at something deeper. Fusion straddles a fraught intersection of civilian science, national security, with implications for energy independence and commercial competition, where companies vie for trillion-dollar markets. The result? Data is curated, filtered, and released only when deemed safe, leaving the public with sanitized highlights, while the raw truths, perhaps hints of unexpected plasma behaviors or novel confinement techniques, remain locked away. This pattern echoes in radio astronomy. China's 500-meter aperture spherical telescope, FAST, a 500-meter-wide behemoth in Guizhou, has emerged as a global leader in detecting fast radio bursts, FRBs, millisecond flashes of cosmic radio waves that could signal anything from magnetar flares to speculative extraterrestrial beacons. In 2025, FAST reported capturing dozens of FRBs alongside transient phenomena like repeating bursts and anomalous polarization patterns. In a field built on global collaboration, these datasets should flow freely to institutions like the Max Planck Institute or the SETI Institute for collective scrutiny. Yet significant portions remain sequestered within China's scientific ecosystem, justified by domestic publication priorities or data processing needs. For example, a 2025 dataset of 47 FRBs, including one with an unprecedentedly narrow bandwidth, was shared only with select Chinese institutions, leaving international researchers to rely on summary papers in Nature Astronomy. The effect is a bottleneck critical data, potentially holding clues to new physics or cosmic phenomena, is withheld, slowing the collaborative engine that drives discovery. This isn't unique to China Western observatories. Like the European Southern Observatories, ALMA have imposed similar embargoes on sensitive datasets, citing calibration or proprietary rights, creating a global patchwork of restricted access. Defense aerospace deepens the shadow. Agencies like DARPA, the US Space Force, and their global counterparts, such as France's CNES or Russia's Roscosmos, develop spaceplanes, advanced launch systems, and orbital platforms with observational capabilities that rival or surpass civilian telescopes. The X-37B, a reusable US spaceplane, has logged over 3,774 days in orbit across its missions by 2025, equipped with sensors speculated to include high-resolution imagers and signal interceptors. These systems, shrouded in classified protocols, can scan Earth or the cosmos with precision we can only infer from declassified snippets. In 2025, reports of hypersonic vehicles and space-based sensors hint at a network capable of detecting anomalies like 3I Atlas, its Sunward Jet nickel-heavy composition, or non-gravitational acceleration. Yet this data never reaches public archives locked behind national security firewalls. We don't know what these platforms see nor how they might intersect with interstellar visitors. We only know they exist, operate beyond public accountability, and contribute to a growing black box of cosmic knowledge where discoveries, perhaps of objects defying natural categories, remain hidden from scrutiny. 3I Atlas in context. Now return to 3I Atlas, where this pattern crystallizes with chilling clarity. NASA's Psyche probe, armed with cameras to map metallic asteroids in exquisite detail, went dark from September 1st to 5th, 2025, during its prime window to image the object. No images surfaced, no explanation bridged the gap, and the October 1st US government shutdown, a convenient scapegoat, came weeks too late to account for it. ESA's ExoMars Trace Gas Orbiter, which observed 3I Atlas during its Martian flyby in early October, initially tagged its data with a surreal 2099 release date, later revised to April 3, 2026, a delay far beyond the norm for comet studies. The Mars Reconnaissance Orbiter's high-rise camera, capable of resolving 30-centimeter details, has yielded no images despite its ideal positioning. Europa Clipper's late October window looms, yet the precedent silence delay absence suggests more of the same. These aren't random glitches. They're a coordinated pattern of withholding mirrored across domains where 3I Atlas's anomalies. A Sunward Jet nickel without iron, a carbon dioxide-heavy coma, a geometric halo challenge the very definition of a comet. Mechanisms of control. The mechanisms of this silence are varied, but converge on a single outcome: restricted access to anomalous data. Sometimes it's archival sequestration, where data is held pending review by mission teams or oversight boards. Sometimes it's algorithmic filtering AI systems trained on normal patterns like comet sublimation, or asteroid orbits flag anomalies, like 3I Atlas's jet, as errors rerouting them to human review or indefinite limbo. Sometimes it's national security, where data with implications for planetary defense or technological superiority is classified as seen in defense aerospace. Sometimes it's international coordination, where agencies align embargoes to prevent diplomatic or scientific chaos, as with ExoMars's delay. In fusion, it's proprietary stakes. In radio astronomy, it's geopolitical priorities. In 3I Atlas's case, it's all of these layered with the fear of a discovery too disruptive, a probe, a machine, or a phenomenon that upends physics. The result is a system where the most paradigm-shifting data is curated, delayed, or buried, leaving the public with polished summaries, while raw truths languish in institutional vaults. The societal stakes. This pattern erodes a cornerstone of democratic science, the principle that publicly funded research belongs to humanity, not gatekeepers. Open access mandates like the U.S. Office of Science and Technology Policy's 2022 directive, requiring immediate public access to federally funded research, or Europe's Plan S for open science, enshrine this ideal. Yet, in 2025, we see a creeping shift toward restriction, where anomalies are treated as threats to institutional authority rather than opportunities for discovery. Who decides what we see? What happens when data like 3I Atlas's propulsion-like jet or alloy-like composition hints at something beyond natural categories? The silence suggests institutions don't trust the public with truths that challenge control. Whether due to fear of panic, geopolitical fallout, or reputational risk, this isn't just about astronomy. It's about the civilization we're becoming, one where knowledge is curated, not shared, and where the unknown is managed, not embraced. The cosmic horizon. As Europa Clipper orbits Jupiter, scanning for signs of life beneath icy crusts, as Hera prepares for its 2026 rendezvous with Didymos, as countless telescopes and satellites, Vera Rubin, JWST Gaia sweep the skies. The infrastructure for detecting anomalies grows exponentially, but so do the filters, AI algorithms, trained on outdated models, review boards, prioritizing caution-classified protocols, shielding sensitive data. If this pattern persists, the greatest discoveries, new physics artificial probes or hybrid phenomena, will vanish into silence, locked in vaults we'll never access. 3I Atlas's story isn't just about a missing window. It's about what we're prevented from seeing. As we await ExoMars's April 2026 release, HiRISE's next data drop, or Europa Clipper's October findings, the focus must shift to the gaps: what doesn't arrive, what's delayed, what's excused by bureaucratic hand-waving. The silence isn't random. It's a signal, a story of institutions reshaping discovery into control. The human question. The true mystery of 3I Atlas may not be its jet, its chemistry, or its halo. It may be us, our willingness to confront the unknown versus our instinct to suppress it. The greatest discovery lies not in the data we see, but in why we're kept from seeing it. As 3I Atlas fades into the cosmic dark, it leaves a challenge. Will we demand transparency, forcing institutions to open their vaults, or accept a future where the stars' secrets are filtered by code and committee? The universe is speaking its jets, its alloys, its silences. The question is whether we'll fight to hear it, or let the gatekeepers dim the cosmic light. This isn't just about one object. It's about the kind of civilization we choose to be, one that chases truth or one that hides from it.